Maybe you can squeeze everything in here. But this is the entire test, right here. Right here. That's the whole thing. So everybody should do well on this one, because there isn't that much stuff to know, right? So here we go. The first part says, find the domain. Now, somebody tell me what pops into my head when I hear I gotta find the domain.
X is greater or equal to 0.
Wait a minute. What? Okay, so I'm hearing something can't equal 0 and something's got to be bigger than 0. But specifically, what can't be 0? The denominator. So if we have a fraction, the denominator cannot be 0. So you might, I mean, whatever strategy works, that's what you'll do. But you might look at this section of the test and say, okay, if there's any denominator, it can't be 0. So do I have a denominator?
No.
No. Do I have a denominator?
Yes.
Yes. So the denominator cannot be 0, so x cannot be 2. That's part of the answer. Is there any denominator?
No.
Is there a denominator?
Yes.
So x plus 6 cannot be 0, which means x cannot be negative 6. So one of the denominator rule, or excuse me, one of the domain rules is denominator cannot be 0. Okay? What's the other domain rule?
Radical, what's under,
What's
greater?
Exactly. She hasn't even been here and she knows. What's under the radical has to be bigger than or equal to 0. Does this one have a radical? Yes. So whatever is under it has to be bigger than or equal to 0, which means x has to be bigger than or equal to 3. Does this one have a radical?
Yes.
Yes. So whatever's under it has to be bigger than or equal to 0, so x has to be bigger than or equal to negative 1. Now notice on that problem, we have 2 answers, because it has both a denominator and a radical. And those are the 2 things that we have to worry about. Does this one have a radical?
No.
Wait a minute. This one didn't have a denominator, and it didn't have a radical, so what do I put down for domain? All real numbers. No radical, no fraction, no issues. All real numbers. Does this one have a radical?
Yes. Oh wait, no.
No. So that's the answer. We already wrote it down. So all of the answers are in the boxes. You simply have got to remember that the denominator cannot be 0, and whatever is under the radical has to be greater than or equal to 0. Okay? Done. Easy. Number 2, this is what we talked about last time. What are the implicit functions? How do we find implicit functions? First of all, notice it's plural. There's going to be 2 of them. What do we need to do?
Oh, get y by itself.
Get y by itself. So however you want to rearrange things, you have to get y by itself. So somehow rearrange the equation so it's just y squared equals. Then what do? Square root both sides. So y equals the square root of x squared minus 9, and don't you dare try to simplify that, because it doesn't. It doesn't. You're just going to get a big red X and some kind of written on your paper. Don't simplify that. You can't. And then the negative of that. And there are the answers to the question. That's all there is to it. Get y by itself.
Just pull up. Yeah, how come it turns into a negative?
How come what turns into a negative?
There's a negative on the bottom.
Yes, because when you take the square root of both sides, you have to take the positive or the negative. It's the plus or minus that always shows up on one
So we can
side
write
where you
that
take the
plus or
square.
minus instead of two different things. Right.
We're gonna write them as two separate equations,
Oh, okay.
because when we put them in our calculator, we have to put them in as two
Right.
separate equations, right? We did that the other day.
Mm-hmm.
Remember, the whole point of implicit functions is, this is a hyperbola, this guy right here is a hyperbola, he is not a function. But if we graph the top half, and then we graph the bottom half, those individually are functions, and when I put them together, I get the whole thing. You don't need to know that's a hyperbola. You need to know these are the implicit functions for it. Now, the next one is probably the hardest part. We gotta find the horizontal asymptotes, the vertical asymptotes, and the holes for this function. Now, there are just some things you have got to remember. You have to remember that vertical asymptotes are cannot be's. So they are going to come from the denominator. Because what do we know about denominators? Think about the domain problems we just did. What do we know about denominators? They cannot be 0. So x plus 1 cannot be 0, so x can't be -1, right? Vertical asymptotes are cannot be's. So you just told me x can't be -1, so my vertical asymptote is x equals -1. That's my vertical asymptote. Whatever x cannot be. Cannot be's come from the denominator. Look at the denominator to get the vertical asymptote. Now the horizontal asymptote, remember this? We compare our x's. We have an x on the top and an x on the bottom. They're not squared, they're the same. It's an x and an x. So what do you get when you put 3x over 1x, Johnny? You get 3. So your asymptote is at y equals 3. 3x over 1x. This problem has no holes. Can anybody remember where the holes come from? Jalen?
If you have to factor, there's something cancels.
If he cancels, that's exactly right. Holes only happen if you can factor and cancel. In this problem, nothing factors, nothing cancels, so there simply aren't any holes. Holes happen when you cancel. I'm sure we'll run into one, but not on this problem. Holes happen when you cancel. All right, let's look at the next one. All right, so this problem right here. And I'm doing the same thing. I'm finding the vertical asymptotes, the horizontal asymptotes, and the holes. So here we go. Where do vertical asymptotes come from? Denominator, cannot be. So I look at this problem, and x plus 5 cannot be 0, so x can't be -5?
Yes.
Which means my vertical asymptote is x equals -5. What x cannot be is your vertical asymptote. It comes straight from the denominator. Now the horizontal asymptote comes from comparing your x's, but we have a problem this time. What's our problem?
Squared.
Well,
Factor.
you can have a square, but this one's not a square. That's the problem. They don't match. So who remembers what we do when they don't match? When you got a squared and a regular x, what do we have to pay attention to?
Factor.
Well, certainly the numerator factors. It wouldn't help me in this case to do that because it's not going to cancel or anything. If the power on the top is bigger. Oh my gosh, was I talking to myself that day? If the power on top is bigger, there is no asymptote. If the power on the bottom is bigger, the asymptote is at 0.
Okay.
Boys and girls, if the powers match, as they did in this case, then you just get the number, whatever the number is. If the power on the top is bigger, there's no asymptote. If the power on the bottom is bigger, it's 0. If you don't know the rules, you're going to miss it every time. Know the rules. Now, somebody said I could factor this numerator, and I absolutely can. But it's not going to do me a single bit of good, because is it going to end up canceling with the denominator? No. So it doesn't matter. You can factor or not factor. It doesn't matter in this problem one bit. However, because nothing cancels out, there are no holes in this problem either. The only way you are going to get a hole is if you can cancel. That doesn't happen very often, but I'm sure you know I'm going to rig one on your test so that it will. All right, here we go. What do you notice about this problem? You got some factoring to do, right? So on the top, let's see, on the top I can take out a 3, and I'm left with x squared minus 9. So my top will be 3x plus 3, x minus 3. You okay with that? Now what about the bottom? X minus 3 minus 1. So we can cancel out these, and we're left with just this. Right? Okay, so that's what I'm looking at. That's what I'm going to use to answer my questions now. I'm going to have a hole. Why am I going to have a hole? Because I canceled. Somebody said 3 canceled, and you're right. That hole is going to be where x equals 3. Because 3 canceled out. X minus 3. 3 canceled out. We're going to finish that in a minute, but let's fill in these. We ought to be able to do these. Where's my vertical asymptote? X equals 1. Why is my vertical asymptote at 1? Because x minus 1 cannot be 0, so x can't be 1. And vertical asymptotes are cannot be's. Now your horizontal asymptote, remember you get by looking at the top and the bottom? Do the powers match this time?
Yes.
Yes, they do. You have an x to the first and an x to the first. Look at the exponents, kids. That's what matters. They match, don't they?
Yep.
So I have 3 x's on the top and 1 x on the bottom.
Yes.
So my asymptote is at y equals 3.
Yep.
Now, could I have noticed that from the very beginning? Would it have worked from the very beginning? Yeah, because they're x squareds, right? So 3x squared over 1x squared. So you could have told that from the beginning.
Will they all be like that? So if you have one that you can have from the beginning, will it end up being the same?
The horizontal asymptote can always be gotten from the original problem. Now the verticals can't, because it looks like this is going to have 2 verticals, so you have to do the factoring and canceling to find the verticals. But the horizontal, you can always tell from the get-go. Now, we haven't done this part before, but we're going to go ahead and do it because we're big kids. A hole is exactly that. It's a hole. It's an open dot in the graph. So it has to have an x coordinate and a y coordinate. You figured out that the x coordinate was 3 because that's what canceled out. If that would have canceled out, it would have been at 1. If that would have canceled out, it would have been at -3. But this is where canceled out, so it's where x is 3. How do you think I'm going to find the y coordinate? I'm going to plug 3 in for x. Isn't that how we always find y's? We plug in x's. Now, be careful. You got to plug it in right here. Don't try to plug it in up here in the original, because you'll get a 0 in the bottom, and that is bad. So make sure you plug it in your reduced problem. So if I put a 3 in for the x's, on the top, I'm going to get 3 times 6, 18.
Yep.
And on the bottom, I'm going to get 3 minus 1, 2. So my whole is at 3, 9. So that means when I go to graph this thing, which I'll do in another chapter, when I graph this thing, I'll have an open circle at the point 3, 9. So when I graph it, it's just going to skip over that point.
Explain to me. So will you always just do that? Will you always do that if you have to factor out like that?
If you cancel, you'll have a hole. Now sometimes we factor and nothing cancels, so you don't worry about it. But if you can cancel something out, you're going to have a hole. The only way you'll have a hole is if something cancels. Okay? All right. That's that part. All right, now we're going to sketch. Very first sketch is a piecewise function. So here we go. All right, so haven't done these for a couple days, but I think you remember how. It's easiest to start. This is your cutoff point over here. So I'm going to go ahead and really lightly, I'm going to draw a line down through x equals 2. That's where my curve's going to get broken. And do you remember that this is where your open and closed dots are then? They're on that line somewhere. Now, to find out where, I'm going to graph each one of these equations. So I'm going to start by graphing 2x plus 1. Now, don't get confused. You've graphed 2x plus 1 since 6th grade. 2x plus 1 is a line with a y-intercept of 1 and a slope of 2 over 1. So up 2 over 1, up 2 over 1. So here is, oh shoot, I was going to do it in purple. There's my purple line. Now, what point on that line is really important to me? The one where it crosses right here?
Yes.
So I'm going to put a nice big dot there. And that dot will be open. And then I'm either going to erase the right part of the line or the left part of the line, depending on what this tells me to keep. This says keep the greater than part, so we're going to lose the less than part. So far, this is your picture. That's all you've got so far. All right, now we're going to graph the second half. Well, what's that? What shape is that? That's your absolute value v, right?
Yep.
So there it is. There's my absolute value v. I'm most interested in this point right here, right? Yes. That's where it crosses my line. That's why I draw that line in there. Closed dot or open dot? Closed. I'm going to erase part of the curve. I always erase part of the picture. In this case, I want to keep this part, the less than part, so I'm going to erase that part. and that's my answer. If you really want to look good, you'll go ahead and erase that line. And that is your piecewise function. Remember, you're always going to have an open dot and a closed dot lined up on top of each other. And one of your curves is going to be shaded right, and one of your curves is going to be shaded left. Or not shaded, but you know, kept. All right. Now we got some easy graphs to do. If you know your BFFs, this is easy. So here we go. We're going to graph x minus 3, sin x minus 1, x plus 1 squared minus 2, x cubed plus 1. All right, here we go. This shouldn't be too bad. What shape we got right here? A V. Now, the normal V looks like this. What happened here?
It goes right through.
Right 3. So 1, 2, 3, and there's my V. I'll label that 0.30 so that my teacher knows I moved it 3 units, and that's it. It's that easy. What's going on here? That's a sine curve. What am I doing to it? Watch it now. What am I doing to it? Down 3. That's going down 3. So I'm going to go ahead. Sines are kind of tricky for me. They're not as easy as V's. Did I say 3?
Yeah.
I meant 1. Down 1. So I'm going to go ahead and sketch in. This is my regular sine curve. Remember how it goes up 1 and down 1? You got to do this carefully. That's my regular sine curve. Now I'm going to take that whole thing and drop it down 1. So that means every point is going to come down 1. Every point is going to come down 1. So the blue one is the answer. I think with some of these, it's easier, I think, if you just go ahead and sketch the original and then go ahead and, you know, move things around.
So isn't the sine one that crosses the
sine goes through the origin.
Okay,
The
so and then
sine goes through the origin.
the cosine doesn't go through the cos.
Well, this is an easy one. What shape is this one right here? This shape is that's a parabola. So that that's pretty easy for me, a parabola. It should be starting at the origin, but this one's not. What's happening to this one? Left 1 and down 2. So left 1 and down 2, and there's my parabola. So that point is the point -1, -2. I went left 1 and down 2 for my parabola. What shape is that? That's your cubing function. That's your squiggly through the origin, right? But what am I doing here? Up 1. So instead of squiggling through the origin, it's going to squiggle through this point right here. Would you agree?
Yes.
So you've got exactly the same shape. You're just going, it's squiggling 1 higher than it was squiggling before. Square root function. What's that look like? What's the basic shape for a square root function?
Dot and then slash over.
Dot and go out like this?
Yep.
That's your square root function. So now you're just moving the starting point. How are you moving the starting point? You're gonna go
Right.
right 3
down
and up
Up
2.
two.
So 1, 2, 3, up 2. So this is the point 3, comma 2, and you got your shape right up there like that. What do you think, okay?
Wait, for the one where it says y equals x plus 1, did you, or wait, that says x third.
Alright, and in the very last section, this is our function operations. So we have an f function, we have a g function, and we're going to do f of 2 plus g of negative 3. That's problem 1. F of 2 plus g of negative 3. Okay. This is easy. How do we find f of 2?
Plug in 2x.
Plug 2 in right here, right? Okay, so that's going to be 2 times 2 squared plus 1. Order of operations, exponents first, PEMDAS. So first we'll do the squaring. 2 squared is 4, times 2 is 8, plus 1 is 9. So this value is 9. Now g of negative 3, put it in the g function. So g of negative 3 would be what?
Negative 9.
Negative 9 minus 4,
-13.
negative 13. So I got 9 here, I got negative 13 here, I add them together, the answer to the problem is negative 4. Same two functions, f and g. Now we're just going to subtract them. F of x minus g of x. Oh, please don't make this hard. F of x minus g of x. Just watch out for your distributive property. Did you get 2x squared minus 3x plus 5? And that's it. That's the answer. Don't do anything to it. It's not an equation. You're done. F of g of 3. F of g of 3. Where do we start? Plug 3 into g. So if I plug 3 into g, do I get 5?
Yes.
Now I'll take the 5 and plug it into F.
Yes.
Again, watch the order of operations. Don't multiply 2 times 5. You start by squaring. So 5 squared is 25 times 2 is 50 plus 1 is 51. So your answer is 51. The answer to the whole question is 51. PEMDAS, PEMDAS, PEMDAS. Exponents first before you multiply. And then g of f of x. Here we go, g of f of x. So we'll start with f of x. F of x is just 2x squared plus 1. So this right here is 2x squared plus 1. So what are we going to do with the 2x squared plus 1?
Plug it in.
Plug it into g. So we're going to find g of 2x squared plus 1, which means 3 2x squared plus 1 minus 4. So 6x squared
Minus 1.
plus 3 minus 4. My answer is 6x squared minus 1. And we just took the whole test in half an hour. Easy. Easy, easy, easy. Oh my gosh. Okay. I don't think I've given you this yet. These are a couple of old quizzes. I don't think. I'm handing these out, so I'm handing out Huh? Okay, so I tried to save paper again, and so this first quiz was two-sided. And I've got it backwards, so the front's actually over here, and then there's another quiz on the back. So would you start filling in fill in those domains, see if you can answer those domain questions, and then we're going to talk about those. I remember the new nurse's name. What is the new nurse's name? Anyone remember? Really? Okay, here we go. Were you able to find the domain for these first three problems? What did you say for number 1, or A? All real. Why is the domain all real numbers?
There's not a denominator.
There's no denominator and there is no radical. So it's a regular old polynomial, so the domain is all real numbers. How about number 2? X cannot equal 2 because we can't have a 0 in the denominator, right? What about C? X is greater than or equal to 2 because whatever is under the radical has to be greater than or equal to 0. Everybody good with that? That happens to be the first part of your test too. It's the first part of this quiz, it's the first part of your test. Now we're going to do horizontal and vertical asymptotes. Alright, so let's make sure we've got this under control. Now on the test, you will also be doing holes. So we'll talk about those as we go through this problem. How do we get holes again?
Cancel.
Yeah, if nothing cancels, you're not going to have any holes. And in a quick look at these problems, I don't think anything's going to cancel. So none of these have any holes anyway. But we'll do a quick example when we're done with these. All right, so here we go. We need vertical and horizontal asymptotes. Let's look at this first problem. Vertical asymptote is x equals 2. Everybody got it? Horizontal asymptote. Y equals 3. As long as the powers are the same, x to the first, x to the first, we just compare. All right, here. vertical asymptote.
X equals -1.
X equals -1. Denominator cannot be 0. X cannot be -1. Cannot be our vertical asymptotes. Horizontal, we got a problem.
None.
It's none.
The powers don't match. You have a squared over a plane X. The squared's on the top, none. When the big power is on the top, there is no horizontal asymptote. Oh, Miss Ford, how am I going to remember that? I don't know, but you have to remember when the big power's on top, there's no horizontal asymptote. All right, here we go. Vertical asymptote. Where is it?
X equals 2.
4x plus 8 cannot be 0. 4x cannot be -8, so x cannot be -2. Your asymptote is x equals -2. When in doubt, write it out. My powers match this time, that's good news. My horizontal asymptote is y equals
1.
5/4.
5/4. Okay.
5/4, right?
Yep.
Vertical asymptote, last problem, vertical asymptote. When in doubt, write it out. 5x squared cannot be 0. X squared cannot be 0. X cannot be 0. Your vertical asymptote is 0.
Same with the horizontal.
Same with the horizontal.
Horizontal, I got a problem because I have x to the first on the top, but I have x squared on the bottom. I'm looking at the powers, not the coefficients. I'm looking at the powers. The biggest power is on the bottom, so therefore your horizontal asymptote is at 0. Okay, now, real quick. Let's suppose this was the problem. Squeeze it in there, down there at the bottom. Horizontal, vertical, and holes. Here we go. First thing you're probably going to want to do when it looks like that is what? Factor it. So let's see. The top will factor as -4 plus 1.
Yep.
And the bottom is +1 minus 1.
Yes. Plus 1.
Your beady little eyes notice that those are going to cancel. And so we will end up sketching or looking at x minus 4 over x minus 1.
Yep.
Right?
Yep.
I need horizontal, vertical, and holes for this guy. Now,
Horizontal.
I am actually going to have a hole this time
Oh, yeah.
because we canceled, right? What x value did I cancel out? -1. What x value did I keep? +1? That means my asymptote, vertical asymptote, is at x equals 1. Where's my horizontal asymptote?
1.
Y equals 1.
Yep.
The only thing left to do is fill in the rest of the hole. You remember how we did that? How did we get the y part of the hole? We plugged in the x part into the problem. Don't go back to the original, it will never work. You have to plug it into your reduced problem, your simplified problem. So if we put in -1, we have -1 minus 4 over -1 minus 1. So what is that? -5 over -2. 5/2. And that would your whole. Give the name or equation. This is number 3. Give the name or equation. You just took a quiz over this. This should be easy.
Logistics.
Okay, so the name would be logistic, like looking at 3A. The name would be logistic,
And y equals
and the equation
y equals 1 over 1.
would be y equals 1 over 1 plus e to the negative x.
Yes.
That's the hard equation. What's B? It's your sine curve, so y equals sine x, or write the word sine. Right, that's the name of it. That's the equation of it. What about C?
Y equals x cubed.
That is y equals x cubed, which is also called the cubing function or the cubic function, right?
Yep.
And what about that last one?
Y equals e to the x.
Y equals e to the x is the equation, and it is called the exponential.
Or function.
And those are kind of easy to keep straight because e to the x is the exponential. Number 4, these are questions, part 4 is on your test. We just practiced some of these. What is the shape of 4A? A V. A V. Absolute value V. And where's it situated?
Negative 1.
To the left 1. So you will draw your little V like this and label this point, and that problem is finished. What about B? What shape?
Yeah, U.
That's a U. And it's down 2. So you're going to sketch this and label that point 0, negative 2, and you're done with that. Takes 4 seconds. What about C?
Left 2, down 2.
Left 2, down 2. Everybody okay with that? And the shape is
A dot. Yeah.
the squaring, or excuse me, the square root function?
Yep.
The square root function? And what about that last one?
Over 3. I mean, up 3.
Now, here's the interesting thing about the identity. If you thought of it like this, it would back up 3, right? But if you think of it without the parentheses, it goes up 3, and it doesn't really make any difference because it's going to be that line anyway. So with the identity, you can think of it either way. All right. I think we will save the back side for tomorrow, and we'll finish that up. So we will